Hey guys, this is Mr. Sal. We're going to look at graphing linear equations. So thanks for watching. Don't forget to like and subscribe and comment about the lesson below. The y-intercept, I think we talked about this just a little bit last time. The y-intercept is where the line will cross the y-axis. And it has a corresponding x value that's 0 because, if we consider this anyways. So if this was our axis right here, try to make that a little bit smaller. And this was the line that was going through those axes. Then the y-intercept would be right there, all right? Well, the x value at that point would be the value of x at on that number line right there, which is 0, which is why the x value is 0. And then we have whatever the y value in this would be, which in this case would be some negative value, but we're not concerned about negativity or positivity. The same is true for the x-intercept. It's where this line crosses the x-axis, which in this case is right there. And its corresponding y value is 0 because on the vertical number line, that value right there is 0. The 0 stuff for the x and y intercepts individually is pretty crucial when we're, on the homework when they ask us to find the x or y intercept. Because we know that one of the values has to be 0, we just got to know which one. All right. So for example, if it asked us to find the y-intercept, we know we would replace the x value in the equation with 0 and solve for the corresponding y value. If it asks us for the x-intercept, then we replace the y value with 0 and find the corresponding x value. Alright, so in this equation we want to find the x and y intercepts. 6x minus 5y equals negative 30. So we'll start with the x-intercept on this one. So the x-intercept. And we need to remember for the x-intercept the y value is 0, and then we'll find a corresponding y value for that. So let's rewrite the equation. That's visible. And we'll find the corresponding x value. So 5 times 0, that makes it pretty nice actually. It just kind of goes away. Now we could show the work on that, which is going to give us 0. 5 times 0, or negative 5 times 0 is 0. But I've made it a phantom 0, which makes that pretty convenient. And to solve for x now, the corresponding x value, I'm going to divide both sides by 6 on this. So that gives me the 1x, which is what we want, and negative 30 divided by 6 is negative 5. So the x-intercept is negative 5, and then the y value, as usual, for all x-intercepts is 0. All right, we need to find the y-intercept, and the y-intercept, we know, has an x value that's 0. So again, we're going to rewrite the equation. But just like we did in that last equation, we're going to replace one of the values, and this one specifically is going to be the x value. The x value is going to be replaced with 0. And I guess we can show the work on this one. So I've got 6 times 0 is 0, minus that 5y equals negative 30. But again, since I've got that 0 there, I'm just going to make it a phantom 0. And now I've got negative 5y equals negative 30. Then finally to solve, I'll divide both sides by negative 5. So that gives me y equals positive 6 now. And the point at the y-intercept would be 0, 6. Now we should be able to graph these 2 points based on the last lesson. Would go to the left 5 on the x-axis for the x-intercept, and then would go up 6 on the y-axis for the y-intercept. So let's find the x and y-intercepts for this equation. Now this is a different type of equation. It's written differently. And that's on purpose. It's in a different form, which we'll get into, not today, well, maybe today, but not right now, all right? All we need to do is worry about which value is 0 for which intercept. So again, let's start with the x-intercept. which has a y value that's 0. So, I mean, if you wanted to, you could start this off by just writing in 0 at the y value and then finding the corresponding x value. Okay? So, the equation, but we know that the y value is 0, so let's replace it with 0. And from here, we're going to solve for x just like we would with any other equation. So I'm going to subtract 3 from both sides. And I got negative 3 equals negative 5x. Then to solve for x, we'll divide both sides by negative 5. And yeah, this is going to give us a fraction x equals, that's going to have two negatives, which is going to make that a positive. So x is 3/5 for a corresponding y value that's 0. Now that's not going to graph very well on the homework. So I don't know. We may not expect to see some fractions like this on the homework, but it's doable, especially if we're doing it by hand. All right, we're going to do the same thing for the y-intercept, but this time the x value is 0. And yeah, in this case, for the y-intercept, the x value is 0. So again, if you wanted to write your answer in with an x value that's 0, that's good. And we can fill in the y value, the corresponding y value in just in a moment. But let's go ahead and replace that x with 0 up there. All right. Well, anything multiplied by 0 is 0. So we got that 0, and we got y equals 0 plus 3 now. I'm going to make that a phantom 0 again, which means that right there I've just got y is 3. There's nothing else to really calculate on that thing. So I've got coordinates of 0, 3. Now this is the nice thing about having this form of an equation is if I want to find the y-intercept, it's pretty easy. All I've got to do is replace the x value with 0, which also means essentially that I can kind of cover that up and see directly what the y-intercept is. Which is why this form is called slope-intercept form, which again we'll get into later on. All right, we need to graph this line that has x-intercept of 4, 0 and a y-intercept of 0, negative 3. Okay, well, let's graph those 2 points first. All right, now again on the homework, this is all you would need is the 2 points. On the test, however, please use 3 points. The reason why we want you guys to use 3 points is because the third point will confirm the pattern. Because here's the thing is let me show you this. Now it's not really related to this problem, but if you got a point here and then a point there, yeah, you can make a line from those two. But if you make a third one that confirms the pattern right here, what the crap is that, right? I mean, you could draw a straight line there. Is it this one or is it that one? We just don't know, right? Which means somewhere in there, it's very likely we made a mistake and we'd want to go back and check our work on that stuff. So we want 3 points when you guys are doing it by hand on the test, okay? And I recommend doing it on the homework as well. Just, again, that confirms the pattern. We don't have to worry about it on this one because they told us what the 2 points are that we need to graph. So let's go ahead and graph 4, 0. That's on the x-axis. 4, 0. I kind of missed it. Yeah, that's good enough. And then we got a point at 0, negative 3, which would be, I'm satisfied with that. Well, that's the 2 points, and we should feel pretty good about that. But we do need to graph the line for these. And how do we graph the line? Well, we're just going to connect the 2 points. All right. So we got that. I don't know. It's kind of a formality just to put some arrows at the end of that thing. I don't know. Maybe it makes us feel better inside. But that's what we would expect it to look like on a test right there. And again, that's just from the 2 intercepts that they gave us. Now in the future, they're not going to give us the intercepts. They're going to give us the equation, and then we'll find the 2 intercepts and then graph the line going through those 2 points. All right, here's an equation. This is called standard form. So we got 5x plus 4y equals 20. And then we can make a table. Sometimes they give us a table and we just kind of fill in the blanks. This is kind of like the last problem from 3.2. However, they won't always give us a table, and you may choose to make one if you feel more comfortable using the table. Well, we may notice from the table, though, is that the two intercepts are included. So the x is 0, that's the y-intercept, and right here the y is 0, which is the y-intercept. All right? So if we calculate these, we'll have the two intercepts, plus we'll have a couple other points to put on the graph, which again should just confirm the pattern. All right? So let's take a look at this. We'll start with x is -1. But right here we're saying that x is -1, so we'll replace x with -1. And from this point we're just going to solve for y. So 5 times -1 is -5. Then we got the plus 4y equals 20. And then we'll add 5 to both sides. And what do we get out of that? 4y equals 25? Eesh. That's not really going to help us. Because this is a fraction, so that's not really completely helpful. But it'll help us to fill in the table, which, again, I think we see that on the homework. So the y on this case, 1y, is 25/4. Or 6 1/4. Now, we could graph this by hand if we wanted to, right? I got an x value that's -1, and then a y value at 6 1/4, which would be, I don't know, about right there. So I put that point on there just because, again, that should pretty much confirm the pattern, whatever we find that it is. Next up, we got x is 0. So I'm going to rewrite the equation again. Now this is the nice thing about this form, is if we're only looking for intercepts, then it actually gets, well, it's kind of easy right here, because I'm going to replace the x with 0 in that equation. And anything multiplied by 0 is 0. So I'm going to make that a phantom 0 and just show 4y equals 20. And then to solve, we're just going to divide both sides by 4. And we get y is 5. So that fills in this box. Now in this box, just like we did with the -1 and 25/4, and it may be, I don't know, a little bit more familiar to see this as an ordered pair. So if it helps you do that, okay. This is an ordered pair 0, 5, which would give us this point. So this should, I mean, assuming we've done it right, should show kind of what's happening in the pattern on this one. But again, this next point should really confirm what is going on in this line, which is the x-intercept, so the y value is 0. Let's rewrite that equation. All right, so once again, I'm going to go into this and replace the y value with 0. And again, anything multiplied by 0 is 0, and I'm going to make that a phantom 0. So I end up with 5x equals 20. And then to solve, I'm going to divide both sides by 5. And I get x is 4. So I've got the point here at 4, 0, which is the x-intercept. That still looks like it's pretty much on the pattern right there. So I got a point right there. But then again, we got this next point, which, as we can see, we do have a pattern, but this next one will just kind of doubly confirm the pattern. Here we go. And I'm going to go in there and replace the x value with 2. All right, so multiplying this out, I got 10 plus 4y equals 20. And then I'll subtract 10 from both sides. This is going to give me a fraction, but again, that's not a big deal on this one. Divide both sides by 4, and I got y is 5/2, or 2.5. So that should give us this point. Well, I feel pretty comfortable now making a line on this thing. So here we go. All right, so we got that line. Once again, I'm going to put some arrows at the edges there. And there it is. When graphing a line, make a table with ordered pair solutions. That's what we just saw. Now, if you're making your own table, again, you only need really 3 points in the table. Graph those points, connect the dots, bam, and you'd be finished. Most of the time, we get to choose values of x, and then we'll solve for y. However, it is possible, just sometimes, that you'll choose values of y and then solve for x. But it's kind of rare to do that. Use convenient values. Now, this is a short list right here. Generally, we're just trying to use values like 0 and 1. well, sorry, and maybe even -1 on there, because we want 3 values, right? So when you choose values of x, choose these values, because they make things extremely convenient, all right? But you don't have to. You get to choose whatever you want. All right, we're going to graph this equation by finding and plotting ordered pair solutions. 2y minus x equals 8. Now we said, usually we would choose values of x and solve for y, which we can do. Now the reason why 0 is an especially convenient value to use is because in this equation, right, actually I apologize, let me show the table on this thing, just like we had before. I got x and y values, and I'm only looking for 3 values. Now again, I'm going to choose x as 0, because in the equation, if I replace x with 0, then it goes away. All right, well, we'll show that. But anything added or subtracting, if we add or subtract 0 to it, is just itself, so that goes away. And we got 2y equals 8. So if we divide both sides by 2, then we got the y value, which in this case is 4. So I got 1 point at 0, 4. Now whether you put that on the graph now or not is up to you. You could find the other 2 points and then graph those. All right, just be careful, because if we graph it now, then we can see the pattern that will be forming. So I am going to put that point on the graph. 0, 4. Next up, we got, we got to choose again. So we got 2y minus x equals 8. But this time I'm going to choose a y value, which is 0. Now again, it specifically has to do with this form, and because I get to choose 0 again, which makes this an extremely easy calculation. So if I replace the y with 0 in this equation, okay, so I am looking for the intercept, the x-intercept in this case. 2 times 0 is 0, so I can just kind of make that a phantom 0 right there. And I've got negative x equals, sorry, that's supposed to be an 8 right there. Now we should look at that as -1, so we'll divide both sides by -1, and I get x equals -8. So I've got the point -8, 0 right here, which we can put on the graph. Now again, this shows a pattern, but we want a third point just to confirm it. Now we get to choose the values, and it doesn't really matter if we choose x or y, we just get to choose. In this case though, I'm going to choose a y value, all right? And I'm going to choose a y value that is 1. Now here's why I'm choosing 1, all right? Because if I choose x as 1, then I'm going to get a fractional answer. Now, it may take some experience to understand why that is fractional. I mean, you could solve it if you wanted to. But for convenience in this case, I don't want that fraction. I want a whole value. So I'm going to say y is 1, then I need my corresponding x value. And this should give us a whole value. So we'll rewrite the equation once again. So 2 times 1 is 2. 2 minus x equals 8. And I'll add 2 to both, subtract 2 from both sides. And I got a negative x equals 6. But again, I'm looking at that as -1x, so we'll divide both sides by -1. And I get x, sorry, that kind of fell off right there, x equals -6. So I have the coordinate -6, 1, which would be, put that on there, -6, 1. -6, 1 right there. Bam. And it is in the pattern. So I should feel a little bit more comfortable making my line on this thing. Here we go. There it is. Alright, we want 3 values to graph on this. Graph the equation by finding and plotting ordered pair solutions. Now again, a table is nice on this thing. You can do it over here, it doesn't matter. And I've got x and corresponding y values. We'll just make 3 of them. Again, that's to confirm the pattern. So we'll start with, and now this is in that form where I can choose an x value that's 0. And then after that, I'm going to choose a y value that's 0, which again should make this a little bit easy on us. So the equation, now that 6 times 0, once again, is going to become a phantom 0. So I got -3y equals 12. Divide both sides by -3. and I get y equals -4. So I have a y-intercept at 0, -4, which should be about right there. Next up, I'm going to find the x-intercept because it is in this form. 6x minus 3y equals 12, but I'm going to replace the y with 0. Now again, this is good because anything multiplied by 0 is 0. So I can make that a phantom 0, and I can solve for the x value pretty quickly by dividing both sides by 6. So x equals 2. 0. Bam. So again, I see a pattern emerge just from the 2 points, but my third point should confirm that pattern. All right. So on this one, yeah, I'm going to choose an x value on this one, but again, I want to keep it something easy to calculate. So I'm going to choose an x value that's 1. So let's show that in the equation. So 6 times 1 is 6, minus 3y equals 12, minus 6 from both sides. And we got -3y equals 6. Divide both sides by -3, and we got a y value that is -2. So that'll go in the table that we have right there. At 1, we got a point at -2. And these are pretty close together, but that's okay. Again, that green point still confirms the pattern, so we can draw the line. There we go. Now the technology that I'm using kind of makes those lines a lot straighter than I could draw them by hand. I don't know. I'll do one of them by hand. So once we get our 3 values, then we should have a pattern that's confirmed in the line. So we got 7x minus y equals 35. And I got an x value. Well, here's the thing. Is if I make the x value 0, the problem with this is I'm going to get a -35 out of that y. Okay. This is only problematic because it will not fit on the graph. So I need to choose a different value. In fact, I'm going to go all the way back. That would be the y-intercept. Let's find the x-intercept instead. So I'm going to replace y with 0, which should give me something a little bit easier to work with. If I do that, then I get 7x equals 35, because my y disappears as a phantom 0. Then I'll divide both sides by 7, and I got x is 5. So I got a point at 5, 0, about right there. Okay. Now, since we have seen that the y-intercept would be far too high, we know that the line is kind of going to be slanted down this way. So when I'm choosing values, I mean, I can choose them close to 0, which would make our calculations pretty easy. However, they're going to be too high as well. Okay, so I've got to choose some values that are close to 5, 0, which means that I could choose, for example, an x value that's 6, and just see what happens. All right. When I do this, I got 7, but now it's times x, which is 6, minus y equals 35. 7 times 6 is 42, minus y equals 35. So I'll subtract 42 from both sides. And I got -y equals -7, which means I can just divide both sides by -1, which makes these positive. So I got the point at 6, 7. Sorry, that y-intercept was at -35. I apologize. So it is going to be like this, which is why we have the point at 6, 7 up here. So that's going up. It's going up really fast. In fact, if we compare it to the other graphs that we had. Well, if I go to the right one more, I'm going to be out of this screen again. So I'm going to go to the left of 5, which puts us at 4 right here for my x value. So that gives me 7 times 4 minus y equals 35. And so I got 28 minus y equals 35. Subtract 28 from both sides. And then we can divide both sides by negative 1, which would give us y is negative 7. So I have this point at 4, negative 7, which would be right here. Now again, this confirms that the pattern is true, the one that we would have had if we had connected the 2 points. So we can just connect these points. See if we can move that over a little bit. That's okay. Oh, I'm sorry. I said I wasn't going to use technology, so let's not do it. All right, here's the thing with graphing by hand, okay, is sometimes when we graph these, because we get a little ambitious, right? Oh, no, that one turned out pretty good. Sorry, that wasn't on purpose, but okay, well, we'll do it in a different example. I like that one. And this one's got the 0. It equals 0. Just don't be tricked by that stuff. The good news is, kind of good, whatever. And we gotta have, well, I need 3 points on that, so x, y. And I can't try x is 0 on this thing, but something interesting is gonna happen on this one. If I replace x with 0, well, that's just 0 right there. So I got negative 8y equals 0. And I can make that a phantom 0 again. So by dividing both sides by negative 8, oh, that's supposed to be 0. Get rid of that garbage. 0. Divided by negative 8 gives me y equals 0. That's 0, 0. So in this case, and this happens from time to time, the x-intercept is also the y-intercept, which means that the line is going to go through the origin. This also means that I can't try y is 0 because it's just going to give me x is 0, which means we may need to be a little creative with the values we choose. So I'm going to choose x is 1 because that's super creative, all right? And it makes things pretty easy to calculate. I take that back. I'm going to choose y is 1. Here is y, okay, is if I choose x is 1, I'm going to get a fraction out of that. Now, that's not such a bad thing, but if we can have whole values to graph, then it's a little bit easier to see. So in this one, I've got negative 4x minus 8 times the 1, and this equals 0. So 8 times 1 is 8, so I got negative 8 right there. Then we'll add 8 to both sides. At this point, we're going to divide both sides by negative 4. Sorry, that's kind of off the screen there. So I get x is negative 2. Now again, this gives us a nice whole value to graph. I got a point at negative 2, 1, which would be right there. The next one, and again, you get to choose, but I'm going to say y is negative 1 in this case. So when I write the equation, 8 times negative 1 would be negative 8, but that's minus negative 8, so I'm just going to make that plus right there. Subtract 8 from both sides, and we got negative 4x equals negative 8. Divide both sides by negative 4, and we get x is 2. So I've got the point at 2, negative 1, which again, this confirms the pattern. And we can draw the line there, something like this. All right, now I swiped that pretty quick, and you know, if this was an ink, that looks like a horrible disaster right there. And we should feel bad about it, okay, because it kind of looks like garbage, right? So as it turns out, and this is unfortunate, but if you miss a point when you graph the line, just make the point bigger. Bam, now it's on the line. Okay? I hope that wasn't too, taxing right there. All right, this one's going to work the same way. Whatever. Now, some of you guys notice, and this happens from time to time, where they give you guys a fraction like this in the equation. But this one can be simplified. which I am going to do right now. And this is not going to change anything because this fraction has the value of 1/2. If you don't like that, then keep them there. Okay? But again, that's up to you. Okay? Now, when we do see fractions, now again, I'm using 1/2 right here, especially since we do choose values of x for this. Now, this is written in function notation. That's just a y right there. That's where our y value is. So you could either replace in the table the y with f of x, or you can replace f of x with y. It doesn't matter. What does matter is the values that I choose for x. Now, as we said before, in this form, it is very nice to choose an x value that's 0 and find the corresponding y value, because when I do that, I get y equals negative 1/2 times the x, which is now 0, minus 8. Well, anything multiplied by 0 is 0, which means this becomes a phantom 0. And again, I get my corresponding y value at negative 8. So I have this point at 0, negative 8. All right, now I'm going to continue to choose x values. I don't want to choose y values in this form because if I do, then I've got to add 8 to both sides, which is kind of a pain in the rear. But if I choose x values, I can just calculate straight across, and I have my y value directly. Now, in order to avoid fractions, which we hate, or most people hate, I'm going to choose even numbers, or multiples of 2, because my denominator is 2. If I choose even numbers, then it's going to cancel that 2 out. Now, we may get some big numbers, and that's okay. But it's going to cancel that 2 out. So let's write this equation in there. So again, if we choose an even value for x, it's going to make this come out real pretty. So I'm going to choose 2. So I'm replacing the x with 2. And negative 1/2 times 2 would be negative 1. And negative 1 minus 8 is negative 9. So that's my corresponding y value. Again, this is why we choose the x values in this case, because it gives us the y value directly. So I have this point at 2, negative 9, right there. Next up, again, we have the same equation, but once again, I'm going to replace the x value with some even number, but in this case, I'm going to choose a negative 2. Nice thing about this negative 2 is it's going to give us a positive value when I multiply these two. So I got 1. 1 minus 8 is y, and y is negative 7. So I got negative 2, negative 7, which gives us this point right there. And now we can graph this thing. That one turned out pretty good. All right. We're going to graph this equation by finding and plotting ordered pair solutions. So it's just a table again on this thing. We'll find 3 values for this. However, you notice the x is not in the equation, which is actually a very good thing. Okay. So if I said, for example, x is 0, just like we've been doing, I don't have any place to replace that x, which means all I really need to do is solve y minus 8 equals 0 for y. So I would add 8 to both sides, and I'd get y is 8. So if x is 0, then y is 8. Well, what if I said x is 1? Well, the equation says that y is 8. What if I said x is 2? The equation says y is 8. In fact, it wouldn't matter which x value you choose. You'll always get y is 8. So let's just graph these points right here, right? So I got 0, 8. I've got 1, 8. And I've got 2, 8 right there. This line is horizontal. So we can graph it. That's okay. And this is the graph of that line. Now what we should notice about this line is that it covers all the points where y is 8. In fact, it would, no matter how big we made this graph. All right, let's graph the equation. X equals 9. Now, again, it does say use ordered pair solutions. So if we can get 3 points on this thing, then we should be in good shape. Now, we do need to be careful, though, because we do need true statements in order to make the line, which means I can't say, well, x is 0, and then y is 9. No, that's not part of the equation, because it just tells us that x is 9. Well, if I choose x is 9, then I can choose any value for y. Maybe y is 10. So if I say x is 9, maybe y is 0. Let's do this the other way, though. All right. If I said y is negative 5, then what is the x value? 9. How do I know? Because it said x is 9. Well, where is x 9? Well, we got these points if we wanted to. I got the point at 9, 10. I got the point at 9, 0. And I got the point at 9, negative 5 right here. And that gives us this line. It's not the prettiest, but it'll work. And I kind of got all the points on that thing. All right, this one does look a little different. That's okay. Once again, we can make that f of x just a y if it helps us to see that a little bit better. I got my table, and I need 3 values for x and y. And in this one, we can't choose x is 0. So I got y equals 6 times 0. Which is 0. So y is 0. Again, this shows the x value. The x-intercept is also the y-intercept at the origin right here. Next up, y equals 6x. But in this case, we can choose an x. Let's say 1. 6 times 1 is 6. Y equals 6. Bam, 1, 6. Right there. And then finally, same idea, y equals 6 times x. But this time we'll say x is negative 1. So y is negative 6. Oh, I forgot to write that in the table. There we go, negative 1 and negative 6. Negative 1, negative 6 is right here. Let's graph that. Bam. That'll do.